last thing that we are going to talk about in this unit is assessing normality. So hopefully we've seen or figured out how important a normal distribution is or how powerful it is. On your calculator, you can do normal CDF to find probabilities or to find proportions. You can do inverse norm to work backwards to calculate like the tallest 5% of adult women or things like that. So it's very powerful if you know that a distribution is normal. The question is, if you have data, how do you know if it's normal or not? You cannot just look at a dot plot and say, oh yeah, that looks pretty normal. No. We can say that for bell-shaped or symmetric, but normal is a very specific label. So there are two ways to assess normality. The first one is the 68, 95, 99.7 rule, and the second one is called a normal quantile plot. Let's talk about the normal quantile plot first. So you see that here. Sometimes it's referred to as a normal probability plot. So normal probability plot, normal quantile plot, those are the same. What that plot does is it either plots X versus Z scores. No, that's what it does. It has X, so these are all of the X values. What's here is if you converted each of those X values to a Z score. So every X value, you convert it to a Z score, that's what goes on the Y-axis. What you are looking for is linear data. So a linear normal quantile plot tells you that the data is approximately normal. And when I say linear, like, it's got to be pretty darn linear. So in this case, we see our data follows really close to a straight line. There's a few points here and a few points here that deviate. That's okay. So what that tells us is this original data is probably normal. We would say approximately normal. Okay, ultimately what I care about is that you can tell me if it's normal or not. But here are a few examples of where something is not normal. If you look at this, that tells you that there's a skew. On C, that tells you that there's an outlier. In B, this is what we call heavy-tailed. All that means is it's a bell shape, but the tails were pulled out. Like a bell shape that is stretched out. Ultimately, though, what I care is that you can look and tell me, linear, the distribution is approximately normal. Not linear, not approximately normal. That's it. We're going to do an example where we make the graph. I don't expect you to, though. So you don't need to know how to do it. You just need to know how to read it. Sound good? Okay. This is the only example that we're going to do. The measurements listed below describe the usable capacity in cubic feet of a sample of 36 side-by-side refrigerators. Are the data close to normal? Assess normality using two methods. Okay, first method. We're going to do the 68, 95, 99.7 rule. So that tells us the percentage of data that should be within 1, 2, 3 standard deviations of the mean. If I asked you to, could you find the mean and standard deviation of this data? Are you comfortable doing that on your calculator? Everybody is? Okay, let's talk about it real quick. Okay, so we have an X bar of 15.825, and we have an S of about 1.217. So if I look at within one standard deviation of the mean, so I take that 15.825 and I add and subtract the standard deviation, that would be all the numbers between 14.608 and 17.04. So within one standard deviation of the mean is all of the values between 14.608 and 17.04. If you trust me, I will tell you it's about 24 of those numbers out of 36, which is 66.7%. Then you would do two standard deviations. So same idea, take the mean, add 2 standard deviations, and subtract 2. You get 13.4 and 18.3. If you count up, that's 34 out of the 36 numbers, or about 94.4%. So far we're pretty well in line with the 68, 95, 99.7. It's not going to be exact. Should be pretty close, but it's not going to be exact in all likelihood. So then lastly, if I do 3 standard deviations, the interval is 12.17, comma 19.48, which is all of the data. So then you're just asking yourself, are these numbers, the 66.7, 94.4, and 100, close enough to 68, 95, 99.7? We're going to say yes. So yes, the data is approximately normal. That is option 1. Option 2 is a normal quantile plot or a normal probability plot. I'm going to show you how to do it up here. You're not going to do it because A, you don't need to know how to do that, and B, it takes too much time in the calculator. Okay, so I'm just going to sketch the plot out. I don't care about any labels, but it looks something like this. So again, yes, our data looks approximately normal. Do you need to do both? No. I'm asking you to do both so that you can see the 2 different methods. But again, the expectation with the normal quantile plot, I will give the plot to you. I will give the plot to you. You are not going to be expected to come up with this yourself.